Hi guys, lesson 22, Introduction to Stoichiometry. Like I said in class today, stoichiometry is basically a process to help you predict how much product you might expect from a given amount of reactants, like a recipe proportion. And since we balance our equations will always be in proportion, and that helps us to make this type of prediction. The example on page S214 starts out how to do that. I'm going to walk through that briefly. It's in your book. So in this one, we are starting with ammonium nitrite and allowing it to decompose and producing water and nitrogen. So it says, how many moles of water might you expect if you have 10 moles to start with of ammonium nitrite? And you get the ammonium nitrite, first you write the chemical equation, and you get that straight off of our list of ions and periodic table. There's your ammonium and your nitrite, resulting in water and nitrogen. Now I want you to remember here that nitrogen is a 2 because it says nitrogen gas, and that is a diatomic gas. So if it's diatomic, then you're going to have at least 2 in your free-floating gas. That will mess you up in these equations. Remember, if you're dealing with a gas, to look at those diatomic gases on page, that's a good question. Hold on a second, I'll find the page for you. Page S190 is where those diatomic gases are. So then you have your formula here, and then they want you to balance it, and you end up with 2 nitrogens over here, 4 hydrogens, and 2 oxygens. On the other side of the equation, you have 2 nitrogens, 2 hydrogens, and 1 oxygen. So we're not balanced. We have 4 and 2. So we have to add a 2 to your water, which increases your hydrogen, and it also increases your oxygen. So it also solves your imbalance on that side. So now you have a balanced equation. That's the second step. Then you take that balanced equation, and they suggest writing 1s in front of the compounds that you have just one of, which is helpful when you are looking at these. So you have 1 ammonium, you have 1 nitrite, you have 2 water molecules, and you have 1 N2 molecule. This is kind of a tricky one. That doesn't count as 2. It counts as 1. Okay? Then they have you look at the question again and make sure you know what ingredients you're talking about. So the question originally asked, if you have 10 moles of ammonium nitrite and you let it decompose into water and nitrogen, what would you expect? How much water? Is that what it asked you? How much water might you expect? So you're looking for your water. Oops, sorry. You're looking for your water, and you want to, this is what you're starting. So here's your start, and here's your end. So these are your key players. And then they want you to check the ratio. And as you can see, your ratio is 1 to 2. We turn the page. It's going to tell us our ratio is 1 to 2. So for every 1 mole of ammonium nitrate, you have 2 moles of water. So for 10, is that what they ask us? 10? 10, you'll have how many? 1 to 2. You'll have, where are we? You'll have I don't know, they go on and on here. Here it is finally. I would say they go on and on. But if you have 10 at a 1:2 ratio, you get 20. Okay? Great. They give you another example, and they don't automatically give you your chemical equation, so I'm going to give that to you. Example 2 is on page S217. You have potassium chloride reacts with fluorine gas to produce potassium fluoride and chlorine gas. Okay, so I wrote it out here. You have potassium chloride and fluorine. It's a gas. I want us to be careful with that. Reacts to make potassium fluoride and chlorine gas. Chlorine gas is a diatomic. Okay, so that's going to automatically be a 2. So, if you look on between your periodic table of elements and your list of ions, if you don't have them memorized, you're going to find your elements for this equation. There we go. So you're going to have 1 potassium, which is K plus 1, chloride is Cl minus 1, plus fluorine, which is a minus 1, produces potassium with your plus 1, fluoride minus 1, plus your chlorine gas, which is a minus 1, but you know you have to have 2 of those for the diatomic ions. So then you go to balance that. You put down your K, your Cl, and your F, and I've covered these. Sorry. I'm trying to make it easier. And you have 1 on this side. There's your potassium. Here's your chloride. Here's your fluorine. There's your 1. On the other side, you have 1 potassium, 2 chlorides or chlorines, and 1 fluoride. So we're not balanced. So we have to do some balancing. So the first thing we want to balance is our chlorine. We change that on this side from 1 to 2. Now remember, this is bonded, so we have to put the subscript out to the top, which also now gives us 2 potassium. So we go chlorine, we go from 1 to 2 to match, but potassium also goes to 1 to 2. So we have to go to 1 to 2 on this side also. And in order to do that, we also add a subscript of 2 in front of the entire molecule, which also brings the fluoride to 2. So now we've gone from 1 to 2 in the fluoride, and on this side we have to do the 2. We do not have to put that in front since it's just a single, so we can make it a subset of 2. So what we end up with a balanced equation, it looks more like this. 2 KCl plus F2 creates 2 KF plus Cl2. And then they suggest to put the 1 in front of the single molecules. This is a 2. Even though this has a 2 subscript, it's 1. This is a 2, and even though this has a subscript of 2, it's still 1. When we go back into our equation then to find what they're asking for, and again it says in example 2, potassium chloride reacts with fluorine gas, with fluorine gas to produce potassium fluoride and chlorine gas. If you begin with 20 moles of fluorine gas, how many moles of potassium fluoride would you expect? So you're looking for your fluorine gas and your potassium chloride. So you put a box around your fluorine gas and your potassium chloride to get your ratio. And your mole ratio here is 1 to 2. 1 to 2. So if you start with 20 moles of fluorine at a 1 to 2 ratio, 1 times 20 is 20. 2 times 20 is 40. You get 40 moles of your potassium fluoride. And they'll give you some other things to do with that. The important steps to remember are on S218 in bold. I don't think you're going to have a lot of problems with these. Good luck, and we'll see you on Monday.